Right now, somewhere over a Chinese city, a small electric pod is lifting straight up off the ground. No runway, no pilot, no steering wheel inside, just two passengers sitting back, watching the skyline drop away beneath them. And here's the part that should stop you cold. Nobody is flying it. There is no human at the controls. There is no human at the controls anywhere. The machine took off by itself. It's navigating across the city by itself. And in a few minutes, it's going to land itself on a rooftop on the other side of town. This is not a concept. This is not a coming in 2030 promo video with fine print at the bottom. This is happening today with paying passengers in real Chinese cities. The vehicle is officially certified. It has already completed over 40,000 test flights, and almost nobody outside of China is talking about how enormous this actually is. Because while engineers in America, Germany, and Japan were still arguing about whether a pilotless passenger aircraft could ever be safe enough to certify, China didn't argue. China certified one, put real people inside it, and started charging for tickets. So how did they pull off something that every aviation expert said was decades away? What does this machine actually look like up close? And why is the rest of the world suddenly so far behind? Let's get into it, because this isn't just a cool gadget. What you're about to see is the opening move in a national strategy that China is backing with policy, with money, and with a target number so big it sounds made up. We'll get to that number, and it changes everything about why this matters. If you love stories about technology that quietly rewrites the rules, hit that subscribe button and turn on notifications right now, because this is exactly the kind of story we track on this channel, and you do not want to miss what's coming next. Alright, let's start with the machine itself, because it is genuinely unlike anything most people have seen outside of a video game. The vehicle is called the XPeng EH216-S. Imagine someone took a giant drone and decided to make it comfortable enough for two people to sit inside. That's basically what this is. 16 propellers arranged across 8 arms, 2 seats, 1 simple screen, and that's it. There's no steering wheel, no pedals, no throttle, no cockpit full of dials and switches. You sit down, the route is already programmed, and the thing just goes. It lifts off vertically. No runway, no taxiing, no pre-flight checklist for the passenger. It climbs, it navigates, it descends, and it lands, all on its own. Your only real job as a passenger is to enjoy the view. And if something feels wrong, there's a single button to talk to the operators on the ground. And think for a second about why 16 propellers matters, because it's not just for show. On a traditional helicopter, you have essentially one big rotor doing all the work. If that rotor fails, you are in serious trouble. On this machine, you've got 16 separate propellers spread across 8 arms. If one fails, even if 2 or 3 fail, the others can compensate and keep the aircraft stable in the air. It's the same logic that makes a multi-engine plane safer than a single-engine one, taken to an extreme. Redundancy built right into the shape of the thing. That design choice is a quiet signal that this wasn't thrown together to look cool. It was engineered from the ground up around the assumption that things will occasionally go wrong, and the machine has to survive it anyway. Now here's where your brain probably does what mine did. Something this futuristic must be experimental, right? Still being tested by a handful of engineers in some lockdown facility? No. And this is the part that matters. In October 2023, China's Civil Aviation Administration issued the EH216-S, the world's first type certificate for an autonomous passenger-carrying aircraft. Let me translate what that actually means, because it's easy to skip past. A national aviation authority, the same kind of body that decides whether a Boeing is allowed to carry your family, looked at a pilotless flying machine, ran it through rigorous safety standards, and officially said, yes, this is fit to carry human beings. No country on Earth had ever done that for a pilotless passenger vehicle. Not the United States, not Germany, not Japan. China was first. And then, in early 2025, XPeng went one step further. It received the world's first air operator certificate for a pilotless electric aircraft. In plain English, it was now legally allowed to run commercial operations, paying customers, real flights, real cities. The machine that looked like the future had officially become the present. And before any of that certification came through, EHang had completed over 40,000 test flights. Sit with that number for a second. 40,000. That's not a prototype someone is crossing their fingers over. To put it in perspective, that's more individual flights than a busy regional airport handles in an entire month, all run to prove beyond any doubt that the thing works. 40,000 chances for something to go wrong. 40,000 chances to find a flaw and fix it before a single paying customer ever stepped inside. Here's what's fascinating about the inside of this aircraft. It's almost aggressively simple. You're not surrounded by instruments. There are 2 seats, a navigation screen showing your route, a communication button, and a small fire extinguisher tucked off to one side. That's the whole interior, and that simplicity is the entire point. EHang's argument is bold. Removing the human pilot doesn't just cut costs, it makes the aircraft safer. Think about it. Human error is one of the leading causes of aviation accidents worldwide. Pilots get tired. They get distracted. In an emergency, they can panic. When you take the human out of the loop entirely and replace them with automated systems that never get tired, never lose focus, and never freeze up, you're potentially building something more reliable than anything with a person at the controls. Now, I know exactly what some of you are thinking right now because it's the same thing I thought. Automated systems can fail too. Software crashes, sensors glitch, and you're right, that's a fair concern. But here's the thing the engineers will point out. A human pilot has 1 brain, 2 eyes, and a finite amount of attention that degrades the longer they're awake. An autonomous system has redundant computers cross-checking each other, sensors watching every axis of movement thousands of times per second, and a ground team monitoring in real time. It doesn't get bored on a routine flight. It doesn't try to push through bad weather because it's behind schedule. It doesn't make the kind of confident, fatal judgment error that has caused some of the worst aviation disasters in history. The question isn't whether the machine is perfect. Nothing is. The question is whether it's more reliable than a tired human. And on that specific comparison, the case is stronger than most people assume. The aircraft hits speeds of up to 90 kilometers per hour and covers 130 kilometers on a single charge. That's roughly the distance from one side of a major metropolitan area to the other, more than enough for a city commute or a scenic tourist flight. Right now, the biggest customers are tourism operators offering breathtaking aerial views, along with government agencies using the aircraft for firefighting, surveillance, and patrols. And these aren't fringe gimmicks. They're foundational use cases already generating real revenue and proving the technology in real-world conditions. Tourism gets people comfortable with the idea of climbing into one. Government work proves it can run reliably, day after day, in demanding conditions. Together, those 2 markets are quietly doing the most important job of all, building public trust, one uneventful flight at a time. But tourism and policing, that's just the warm-up. This is what makes China's flying car story completely different from every flying car story you've ever heard. Startups all over the world have been promising flying cars for decades. Companies in the United States, Europe, and Japan have unveiled gorgeous concept vehicles, raised billions of dollars, and generated mountains of press. Some made real progress, but almost all of them are still doing the same thing: waiting. Waiting for regulatory approval, waiting for infrastructure, waiting for public trust, waiting for someone, anyone, to say, yes, you're allowed to do this. China skipped the waiting, and to be clear, that's not an accident or luck, it's structural. In most Western countries, certifying something this radical means years of cautious back and forth between regulators, lawmakers, insurers, and the public, and any one of them can stall the whole thing indefinitely. Every party has an incentive to avoid being the one who said yes if something goes wrong. China's system works differently. When the central government decides a technology is a national priority, the regulators, the local governments, and the state banks all move in the same direction at the same time. You can have serious debates about the trade-offs of that approach, and people do. But on pure speed, it's not close. Where the West asks, what could go wrong if we allow this? China's system asked, what do we need to build to make this work? And those 2 questions lead to very different places. In 2024, the Chinese government wrote something called the Low Altitude Economy directly into its annual National Work Report and officially labeled it a new growth engine, sitting right alongside electric vehicles and renewable energy. Now, when the Chinese government put something in the National Work Report, that is not a polite nod. It means policy gets shaped around it. It means local governments get evaluated on how well they support it. It means state-backed money starts flowing toward it. It's the difference between a hobby and a national mission. So what is the low-altitude economy? It's every commercial and civilian activity happening below 1,000 meters of altitude. Drones delivering packages, helicopters doing medical transport, and yes, autonomous air taxis carrying passengers. China is building the entire ecosystem at once, not just the vehicles, but the regulations, the airspace management systems, the landing pads, and the communication networks to coordinate all of it. And that all-at-once part is crucial because it's where everyone else has stumbled. It's no use having a brilliant flying taxi if there's nowhere to land it, no system to manage where it flies, and no laws that permit it. China understood that you can't build the vehicle and figure out the rest later. You have to build the car, the road, the traffic light, and the rulebook simultaneously. And here are the numbers that show the scale. By 2025, there were roughly 57,000 companies operating in this sector across China. City governments are building vertiports. The national economic target for the sector is 1.5 trillion yuan for 2025 alone. And that's projected to rise to 3.5 trillion yuan by 2035, 3.5 trillion yuan. That's not a startup's pitch deck dream. That's a coordinated industrial strategy, and it's already in motion. But here's where it gets genuinely unexpected, because the EHang air taxi, remarkable as it is, isn't the only flying vehicle making headlines in China. There's a second company taking an approach that is almost philosophically opposite. It's called Aerospace, and it's affiliated with XPeng, one of China's leading electric vehicle makers. Their product has a name that tells you everything about its ambition: the land aircraft carrier. Picture a large, sleek, six-wheeled van, a proper road vehicle you can drive anywhere a car can go. A parking lot, a campsite, a scenic hillside. But hidden inside the rear of that van is a compact flying module. When you want to fly, the back of the van opens. The flying module slides out, and you lift off from wherever you happen to be parked. The control stick inside operates both the van and, with training the company claims takes under 5 minutes. The aircraft too. When you land, the module folds back into the van. You drive home. You park in your normal spot. You charge everything overnight off the van's own power system, which can recharge the flying module for up to 6 full flights. Think about what that actually solves. Every flying vehicle concept for the last 20 years has been haunted by one problem: infrastructure. Where do you take off? Where do you land? Aerage's answer is brilliant in its simplicity. You don't need vertiports at all. The ground vehicle becomes the infrastructure. No dedicated landing pads. No special license beyond a standard driving permit. And this is where the two companies tell you something fascinating about how China is hedging its bets. EHang is betting on a centralized future, fixed routes, vertiports, an air taxi network that works like a subway in the sky. Aerage is betting on a decentralized one. Every owner carries their own launch pad with them, fly from anywhere, land anywhere. Nobody actually knows yet which model wins. Maybe it's both, for different uses. But instead of arguing about it for a decade, China is simply building both at the same time and letting the real world decide. That's a luxury you only have when an entire national industrial machine is pointed at the same goal. And the range backs it up. The van itself travels over 1,000 kilometers, and combined with 6 recharge cycles for the flying module, you could drive a long distance, fly over a stretch of terrain that has no roads, land, fold everything up, and keep driving. Now, the price. One of these will set you back somewhere between roughly $30,000 and $400,000 US. That is clearly not a mass market product. Not yet. The first units rolled off the line in Guangzhou in late 2025, with around 7,000 pre-orders already placed and certification still being finalized for deliveries targeting late 2026. But here's the thing about technology pricing. It never stays where it starts. The first smartphones cost a fortune. Electric cars were once pure luxury. Flat-screen televisions were once a status symbol that cost more than a used car. Scale, competition, and manufacturing efficiency have a way of dragging the extraordinary down into the affordable. The land aircraft carrier is today's premium toy, but it's showing us what tomorrow's mainstream could look like. At this point, you might be thinking, okay, impressive, but it's still just a fancy ride for wealthy tourists and government agencies. What does this change for regular people? The answer is hiding in the architecture of cities themselves. Urban traffic is one of the defining problems of the 21st century. Our cities were built for walking, then retrofitted for horses, then bulldozed and widened for cars. We layered on flyovers, underpasses, ring roads, and the traffic got worse anyway. Every city planner knows the uncomfortable truth. You cannot build your way out of congestion on the ground. Every new road just generates new demand that fills it right back up. The sky has no such problem. Right now, the airspace above our cities below 1,000 meters is almost completely empty. There are no traffic jams at 300 meters, no potholes, no traffic lights. Low-altitude vehicles change the entire geometry of how a city moves. Think about what a city actually is. It's a flat surface that we've been fighting over for centuries. Every road, every parking space, every intersection is a negotiation for a tiny piece of two-dimensional ground. The sky takes that flat surface and turns it into a stack. Suddenly you have layers of usable space where before there was nothing but air. A journey that takes 45 minutes in stop-and-go traffic could take under 10 minutes by air. Emergency services could reach any point in a city in minutes, regardless of what's happening on the ground. Medical evacuations, firefighting, real-time response, all of it improves the moment you start using the sky. And for rural and mountainous regions, of which China has an enormous amount, the implications are even bigger. Communities that are hours from a hospital or a market by road could be minutes away by air. Picture a village high in the mountains where a sick child currently faces a 4-hour drive down winding roads to reach a hospital. Now picture that same trip taking 15 minutes in a straight line over the peaks. The access gap between cities and the countryside, the kind of gap that has defined economic inequality for generations, starts to close in a way that roads alone never managed. You can't build a highway to every remote village. The terrain and the cost make it impossible. But you don't need to build anything on the ground if the vehicle simply flies over it. This isn't just transport innovation. It's infrastructure that rethinks what the word nearby even means. Now, I want to be straight with you, because this is where most videos oversell it. This is not solved. The vehicles are still expensive. Public trust takes time. A lot of people are not ready to climb into a flying machine with no pilot, and that hesitation is completely reasonable. Scaling an entire airspace management system for thousands of autonomous pods over a dense city is a brutal engineering and regulatory challenge that nobody has fully cracked yet. Imagine thousands of these things in the air over one city at rush hour. Every one of them needs to know where every other one is. The weather has to be accounted for, and a single coordination failure can't be allowed to cascade. That's a genuinely hard problem, and anyone telling you it's already handled is selling something. And other countries are not asleep. The United States, the European Union, and South Korea all have serious programs chasing similar certifications. But here's what China has that the others don't. Proof. Not a prototype, not a concept, not a rendering. An actual certified flying taxi that has completed over 40,000 flights and is now carrying real passengers in real cities. In a race where everyone else is still asking, can this be done? China already answered the question and moved on to how fast can we scale it? And that gap, the gap between asking the question and answering it, is the kind of lead that compounds. Every flight generates data. Every bit of data makes the next vehicle safer and cheaper. Every safe flight makes the public a little more comfortable, which makes regulators a little more willing, which brings more investment, which funds more flights. It's a flywheel, and China started spinning it years before anyone else. There's a moment from a journalist's ride in one of these e-hang taxis that stuck with me. Sitting there, no pilot beside her, she says out loud, half to herself, "I'm not going to look down." And then, almost immediately, Am I going to look down? That little moment captures the real story here. Because for all the policy targets and trillion yuan projections, the most significant shift isn't economic. It's psychological. For all of human history, flight meant extraordinary machines, years of training, and enormous infrastructure. It belonged to specialists, pilots, engineers, the military, the wealthy. What these autonomous electric vehicles are doing, slowly then suddenly, is turning flight into something ordinary. Something you could one day order on your phone the same way you order a car today. And once something becomes ordinary, it stops feeling like the future and just becomes life. The future, famously, is already here. It's just not evenly distributed yet. And when it comes to flying without a pilot, China just moved the distribution a whole lot further along. The question is no longer whether flying taxis become part of daily life. That question has been answered. The only questions left are how fast it spreads, how cheap it gets, and which countries are ready when it arrives, and which ones are still standing on the runway, watching, asking whether it's even possible, while the rest of the world flies overhead. So, I want to hear from you. Would you step into a pilotless flying taxi right now today? Or do you need a few more years before you trust the machine? Drop your answer in the comments below. I read them. And if this blew your mind even a little, hit subscribe and ring that notification bell, because this is exactly the kind of story we're going to keep tracking as it unfolds. See you in the next one.